Uh, Good morning, all, or good afternoon, depending on what you are, where you are. Amit, maybe could you just try to check if you can project so that we can then start?
Can you see my screen and my mouse?
Yeah. Okay.
Can you hear me well?
Yes. Good. So I think we can start at this point then. So welcome all to this webinar, which is organized by ETSAP for the new season. The topic is focused on a new feature that exists in Veda 2, the feature for creating reports. I've used this feature sort of a couple of weeks ago for the first time, basically, and I've seen that it's quite powerful in order to produce outputs or produce reports from outputs of several scenarios, which can be much faster than the old approach of just updating an Excel file, which we were using so far. So I just give the floor to Amit to basically explain the layout, the setup, and the details of this. Again, the webinar will be recorded, so it will be available under the ETSAP YouTube channel. I suppose, Amit, you will do the presentation, and then if people have questions, then they can just come in and ask, right?
Yes. Can you hear me still?
Yeah.
And you see my screen, right?
Yes, all there. So I'll leave it to you then.
Okay. So please feel free to stop me at any point, because it is difficult to give webinars without. It will be very good if somebody can go and say, so that I know that everything is still working and I'm not talking to myself. Because for some reason I've also lost controls and I cannot see the Zoom thing.
What do you mean?
I mean, I can, okay, now I can see the, the control panel of Zoom itself.
Okay.
Okay, so what I'm going to present today is again something that has been evolving over a very long period of time. And this is something that was started when I first submitted 500 variables to one of those EMF meetings from TM. So the first iteration was done with, update Excel and all that, and it was an overnight 24-hour operation to do that, and it was quite painful. So from that point, I started a different approach, which has been recently improved a lot with the Veda 2.0. Because before that, it was all in small pieces and it was not possible to share it with others, but now it's in a form that it can be shared. So that's why I've made it an optional feature in Veda 2, because there's really a completely new functionality, which is way beyond what the old Veda had. So it is, well, it's not completely documented, but quite well documented in the report section of the Veda documentation. So I'm using, I could show you some slides from the documentation, but I think it's better to start with a live example, because I think it will be a lot clearer like this. And I'm using the advanced demo model, which is on GitHub, and I'll send you an email or just put a message somewhere, but this model is accessible to everybody. And this is, this is the last demo model with some advanced features like electricity regions and so on. But anyway, so this is the model that I'm using for this reports demo. So Let us start with a typical reporting requirement that you would have. And this is right now the results section of Veda 2 itself. So we're not starting with reports yet. So typically you would want to see final energy, let's say. Okay, so you have final energy. I have selected only one scenario. So how do you make final energy? You have where Fn, you have sets for process, for sectors basically, to identify sectors, you have process sets. And then to aggregate commodities, you have commodity sets. So typically this is how you would make a final energy view using Veda backend. Using the results functionality, the native results functionality, or the original results functionality of Veda. So that's fine, it works well. The only problem is that you have you have sectors, you have fields. But now if you want to introduce end users, you can't do that in the same table. You will have to make a separate layer of sets, which will be partitions of these sets to create end users, and then it will not be possible to then see the sector view. So it is possible, but it's painful to see more detail in this. The other thing is that even for this tiny example, there are 7,000 rows in this table because electricity is time sliced and so on. Okay, so that is how you would do it in a conventional way. Now, what this new functionality lets you do is it lets you create a report definition in an Excel file. So this is the core of this new functionality. So you can create. So right now, all we are doing is seeing an alternate way of grabbing information from the results. Okay, so instead of seeing lists and instead of seeing all those scenarios and so on, you just have a definition file, which is called LMA defs is the keyword. And LMA defs, anything would work for this definition file. So we'll just start with one tag, which is TS definitions. It used to stand for time series. So you have attribute, you have set. So you have the standard filters plus some more. So let us just see how you can grab the final answer. So one way to do that is to say that I have commodity sets, which are COM star and RSD star and TRA star and so on. So I have listed commodity sets under CSET set. And I have said that Fin of these commodities into DND and PRE is what I'm interested in. Okay, so I just say that, and I say that I know the units are category, so PA, and I give it a name. Okay, and I just do this much. So let's see how this is right. So to trigger reading of that file, you have to go to this menu, which is active for everybody till the end of this year. And you say create a new report. You select the model. And you say get, then it shows you all the scenarios that are available for that model. So I just select one scenario. And I give this report a name. ETSAP webinar test 1. And I say create. So it will go and read the sys settings file because there might be unit conversion. It will read the set definitions file, and it will read this LMA deps file. And then it will process the declarations. And it will produce something. So variable var_bl is what we had fin n, final energy, as the variable. So, and the browser is exactly the same as the results and browse and so on. So there's nothing new. And we say get data. So we get this. So by default, it aggregates across all the dimensions apart from scenario and region and period. Okay, so because we didn't do anything else, it has simply added the flows of all those commodities into all those processes and by region. So that's it. That's what we get. Okay, but notice there are only 18 records. Yes, of course, everything is aggregated. Fine. So now let's take the next step. So we would like to see the process commodity detail. So the way to do that is simply to say in show me, I want to see process and I want to see commodities. Okay, so I save this. I go back to my report and I can simply say refresh data. Because I have modified that file, it will be read again. And it will now produce a view which is, so I had saved that selection, but it's basically only the variable, fin n, so fine. So now we have process detail, we have commodity detail. Okay, so fine. I mean, it's still not very useful because we don't have the sector and fuel as aggregations, but at least we have the detail. And notice again, we have very few records because the time slice is still collapsed. Okay, now why is this so nice? We can dynamically add dimensions. Now, what does that mean? That I have the commodities. So let's see here. So here I have the commodity. So I can extract the sector and the fuel from here, right? I can say, if I can say AGR star is agriculture, com star is commercial, and so on. So I can create a table like this. So just focus on this. This instruction is saying that read the commodity column, add a dimension sector if the name, add a dimension sector and call it agriculture if the name is AGR star. Call it residential if the name is RSD star, and so on. So with this one, we can add sectors based on commodity. Now we can go on doing this. So we say now that if the name is like HET, then create a dimension fuel. And if the name is HET, then call it heat, and so on. So just based on commodity, so I had, because of this row, it was ignored, but now it is active. So now it will create sector and fuel dimensions based on commodity name. Okay, so we close this. We go and we refresh. Now, so now what that did was it created a dimension sector and it created a dimension field. So we have reached where we were with our conventional approach, right? In a different way, in a slightly cryptic way, but efficient. I would say it is efficient to be able to define things like this in a separate file. And we have this, but now we can go further. How do we go further? I would like to see this broken out by use in the same way. So for that, what I can do is I can use the process names now and say that if the process is called CAP star, then it's commercial appliance. If it's COT, it's other, CSH is space heat, IDM is other, industry or labs, and so on. TCA is cars, TPU is public transport. In addition, I can, if I want to say that I want to distinguish between old and new technologies, so now this is also very interesting that like in Veda overall, it is, it is sequential in the sense that this will overwrite this one. So I create a dimension old new and I make everything, and I will just exclude the electricity technology from here. So everything I call old, and then the technologies that end in one, I'll call new. Okay, so now I'll activate this one. So this one will now add two dimensions, end use, which will be based on process names, and old and new again, which is based on process name. And now let's see what happens. So now we have the sectors, and we have the end use, and we have the field, and we have old new. And we still have process and commodity. And just notice that we have only 452 rows, elements in this view, which is so much more informative compared to the 7,000 that we had in our conventional approach. And we can make it better because we actually don't need the process and commodity. This is there only to check. So once we are happy that all the classifications have worked well, we can go and delete this detail from show me, and it will still keep, it will still keep working. That's something we are straightening out with George. So any questions? This is clear. You see the basic thing is that you, so the basic thing is that you can freely add dimensions based on process, commodity, even region, and some other dimensions. Okay, so now we'll work on the efficiency part. And now I don't need to see this anymore. So it will be smaller. Okay, anyway. We'll see that in the next iteration. So this was one complete way of making a view. So the final energy view, which was very rigid and it was made like this in the conventional form, has been made differently where you can see a lot of additional detail with fewer records. Okay, so that is one section in a way of the presentation. So if you have any questions about this, please ask now, because it will go to a slightly different mode after this. Everything is clear? Am I still audible?
Yes, you are. Yeah.
Okay, so that was one way of extracting data. Another way of doing it is with lists of sets, because the approach that I just showed is okay for final energy, but it will not work so well for electricity examples, for example. So now let's say you want to see, in the conventional sense, if you wanted to see capacity generation and fuels, electricity. So we typically make it like this, that you have process sets and capacity. For capacity, then you will have F out and the electricity commodities and the same process sets, and then fuels, you would have Fn and commodity energy and these sets. So if now let's try to replicate these reports with the, these views with the reporting feature. So for that, there is an alternate mechanism, which is, so let me, okay, so we already had this one. Now I've added a few more rows here. So just look at this one for now. So what I have is a list of process sets under pset set. Okay, I have var f out. So I'm trying to make the generation table. I have a list of pset set, var f out, commodity C set Cn is ELC, unit sino or 32. And I give it a name eprod, and I embed p set in angular brackets in the name. So this is a convention, which means that if there is an angular bracket p set, then it will create an eprod variable for each of the sets that exist in this column. There is one more requirement, because I don't want to see eprod ELE bio. I don't want to see, I don't want to see this literal name. So there is another tag, pset map, which lets you give intuitive names to your set names. So ELE bio is bio, ELE col is col, and so on. So that when you see the report, actually, your variable will look like eprod bio, eprod col, and not eprod ELE bio, and so on. So at the same time, we add some other variables, eprod, ecap, EMI, and efuel. So eprod is that, ecap is var cap of the same sets, EMI ELE CO2 is again the same sets, and F out of ELC CO2, and Fn for the same sets for set NRG is the fuel consumption. Now these stubs, eprod, ecap, EMI, ELC CO2, and efuel, they are reserved words in a way, because they drive the computation of very useful Uber variables. So capacity factor, CO2 emission intensity, and efficiency for electricity power plants, which is freely aggregatable. I'll show you how. But let me know if there are any questions about this for now, about this definition. So this definition is of a different type. And now when we process, it will process these additional variables and not just the final energy. Okay, so we go back to our sim report. And so notice that the variable list had only one item. You'll see quite a few more now. So what we had defined was these EPROD, 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 so bio, coal, gas, hydrometer, this, EMI, ELC, CO2, E-fuel, ECAP. These other ones are additional, like I said, they are reserved words, the stubs are reserved words, and they produce these capacity factors, CO2 intensity, and efficiency. So let's start with EPROD. So I can select all EPROD and get data. And okay, yeah, actually, okay, I skipped one step here because normally we would come here like this. No, so this is again, I don't want to see EPROD in my presentation view. So I would like to create a dimension tech. And I have done that by this. So variables can also be used. And since I know that these names are embedded in the variable name, I can create a technology dimension using that. So this I simply copied from here because I know that this is what will be the last part of these variables. So I can add a tech dimension from the variable name. And then to make it easier to grab things, I created an attribute dimension that fin is final energy, prod is electricity generation, and so on. And process map is the same, commodity map is the same. So that's it. So this helps in creating the technology dimension, which creates a very readable view. So that's generation. Now let's look at one of these Uber attributes, variables. So capacity factor. Now what I meant by this being really aggregatable is that this is a weighted average, and you can see it in any expecting technology there. So these numbers make sense for different aggregations. So gas is 85%, hydro is 50%, and this. And if I remove the region, it will adjust for that. So this is a dynamic weighted average which keeps showing you the right picture, which is something which would be. You cannot do that in Excel. You will have to make many different views to be able to do that, and it is done so easily here. So capacity factor, efficiency, and CO2 intensity. So similarly, if you look at And you can look at entire regions if you want. And like that. Any questions? No, we'll finish before time, I think.
No questions there.
Weighted average price for electricity would be interesting.
The weighted average price, yes, that was, it is also there, but I have not created an example for that here. So weighted average price is also there, but for that, it is also possible to grab one of these demands, which are pure electricity demand. We can also do that. But yes, weighted average, volume weighted by time slice is a part of this demand. I have not created an example. So, the other very important and interesting thing here is that this is extremely efficient. This whole thing is very efficient because it happens. There's a lot of parallel processing that is used at every step in this version of Veda. So here, for example, if I were to let all these, I just ran 21, there are 22 scenarios here. So if we were to look at final energy for so many scenarios, it will take some time. Although this is a very small model, so may not be that much, but just imagine what happens to the size. And here, if I created a report with all scenarios, it will almost take the same time. So let's say I wanted to select all scenarios, all 22. You see, this is processing all scenarios in parallel. All the scenarios and questions?
I am. It's just a quick question. Would it be possible also to create basically, I don't know, variables or something equivalent for regional groups, or is not possible?
Region groups?
Keep it in mind that
yes, exactly.
and they send you the
So yes, you can create, just like you have a variable map, process map, commodity map, you can have a region map. The sheet name is not important. But this one is important. And I can say region group and minus reg star, because there is reg 1, reg 2 and electricity regions. So minus reg star is elect reg and reg star is demand reg. Okay, because in this one we have so these individual countries are used for electricity and reg 1 and reg 2 are used for the other sectors. So we have created a region group saying that what is not called red star is electricity region and what is called red star is demand region. So this can be done. Another thing we can see in this iteration is unit conversion. So it is possible to convert units. Well, you can do it in the cube also, like you can in the regular results thing. But this can be useful if you want to do some negatives, like Auntie had asked once. So for example, if you have sequestered CO2 or you want to do something different, you want to have consumption as negative numbers, then you can do that with this facility. So, okay. So now if we went back to our old report, although we can use this one also, but let's use the smaller one. So you see this took 43 seconds to process and the one with single scenario took 24 seconds. So I can refresh this one to see region groups. But yeah, here. So we see this. So actually, it will not be very useful in this particular example because the regions are different by sector. But basically, you can do it is all I can tell you. So because now in the final energy view, you will not have any electricity region. Let's see. And in the electricity views, there will be no. So you see there is only one region group, demand region. So this mapping business can be done for variable, process, commodity, and for regions. So in fact, if you see the EU Times, there is also an elaborate file in the EU Times for public on GitHub. There I have created Balkans and EU27 and non-EU27, that kind of sets for regions. And if we look at so the original units of these were KT, and this is empty now. You see, this has happened because of the unit conversion. Because in the original definition here, the units were KT for EMI-ELC-CO2. But then I had a unit conversion, which was saying that if you find KT, then call it MT and use this multiplication factor. So that has been applied, and you see MT as the unit. There are many more things I can show, but I thought I thought we'll go slower than this. So I'm not really, because there is a whole functionality with auxiliary time series called ATS, where you can inject population, GDP, and historical final energy and primary energy numbers, so that you can see them in the same view for calibration, and also to draw charts which are linked to history. So, is there a question? I hear from the microphone.
Yes, Amit, hi. I would like to pose a question. It's Luc from Vito. I was wondering, is it possible to define, for example, a process set that is dependent on the process having a certain attribute, and to make it more concrete? Let's say I want to dynamically group all processes that have a Veda out of electricity, not using the name, but really the result.
Okay, so for that, you have to use this approach, this one. In the process map table, it is only based on name.
Okay.
Okay, but if you want to have a more complex definition of the set of, then you can use the other approach, which is this one.
Yeah.
Although what you are saying, I have been considering expanding this, because there's no reason. I have to talk to Rohit, and maybe we can generalize this beyond name, but I'm not sure. And it might also become more confusing, because now there will be multiple ways to do the same thing, but that's always the case with Veda. And one more point here, that this thing works with CSET and CNAME also. So you can embed CSET just like you are embedding presets, and for that you will have to create a CSET map, just like there is a CNAME map. And you can have multiple in the same name. So I could have ESET _ angular bracket CSET. So the permutation will be handled. So you can create really complex variables like this very efficiently.
Okay, thank you.
Just to repeat, you could have a list of CSETs here, list of PSETs here, and embed PSET and CSET in the variable name, and it will create all the variables.
Okay, that's okay. Thanks.
Any other questions?
Hi, I'm James Glynn here. How's it going? I see in there's an equation in the browser window that you have, basically defining the aggregation rules. It's a sum over the attributes, or a sum of the sets or whatever that you're trying to work on. Is there a way of changing those aggregation rules so that they're like averages of the query, or max or mins, or pulling different statistics out of the query?
You mean here?
Yeah, exactly.
Yeah. You tell me what you want to see, because yes, it is possible to use things other than sum, but I have not been able to find averages could be useful. So why don't you start a thread on the forum or something to discuss what would make sense?
Okay, will do.
What are the aggregations to make sense?
I'm just thinking of, if you have a group of, it's probably more so for comparing scenarios rather than, or states of the world maybe, rather than individual processes, and you want to see, I don't know, the max, min, and average capacity factors or something from a selection of scenarios.
Yeah.
Anyway, I'll start a thread and see.
Yeah.
Okay.
And another thing about reports, which is different from results, is that this can go across models. You can when you create a report, you can select scenarios from different models. Now, when I say different models, you would normally not select. It would not make sense to select scenarios from JRCU times NTM, but you could have different versions of the same model, which is often the case. You are using a model for a project, and there's a slightly different version which is called different in your Veda, which is so you may want to compare scenarios across those, and that is not possible easily in the in the regular results unless you import the VD file, and if they happen to have the same name, then it won't work. But in this case, what will happen is that when you create new, you could select, like in this case, there are two different study names. Now, study name is another thing which comes with the advanced version of Veda, where you can distinguish the same set of runs, but I could do this, so these are two different versions of the same model. And then when I say get, I may get the same scenario, which has been run by from two different models, and it will keep on working because model is a dimension here. The model remains a dimension, and study remains a dimension, and user remains a dimension. So we can do a lot of different things, compare a lot of different things very easily in the reports functionality. And the unit conversion, which exists in regular one, continues to work here. And finally, this browser is all right, and it is, it is good to see these things. But so let's say we are looking at final energy. So if you were to create a CSV, then it dumps all the fields, even those that you were not looking at. And this can be this can go into Tableau or whatever else you might be using Power BI Tableau. So it is a very efficient way of a first step of data analysis, data massaging if you are doing a large number of runs with a complicated model. And actually this another thing that is in the works is to be able to see this on LMA. Now LMA is not the whole report functionality is quite useful even without LMA, but LMA is really something that makes it far more even more powerful. So let me give you a glimpse of that. Do you see a browser or you still see Veda?
We see the desktop.
You see desktop, you don't see
No, sorry, the browser, so the LMA is working.
okay. So so it is the same data, which can go into a viewer like this. And then you can create splitters, slicers very easily, and see these things in a very dynamic way. And the main feature here, which is not available in the local one, is this possibility, to split along any dimension very easily. So let's say I want to see the sector side by side. So I can see the sector here, and the scenarios can go somewhere else. So I can do, this one makes sense, but like that. So it is the same data, but then it becomes much more insightful when you have a web interface. But this is not the only web interface. You can be using Tableau or Power BI or something else. But soon there will be a way to send results from the reports feature of Veda 2 to this interface. So that's what we are working on. We have to change the way we have deployed this, because right now this is working on a physical server in our office, and we have to deploy it in the cloud to be able to do open it to all users. Luke, you have something to add, because this is Luke's model that I'm showing, the Australian model, and recently we have one more comment, that you can actually create Sankey charts from this definition. So of course it takes more work, but the Sankey that you'll see is created using this reports feature. Just by adding appropriate dimensions, you can create Sankey charts. And Sankey is a visualization on this platform. But you need to create these dimensions appropriately. It takes some work, but it is possible.
Yeah, I can make some comments. So, yeah, I mean, like everyone else, you do various projects and produce results, and a lot of the times they're static from the processing in Excel from results, producing different charts, etc. But a recent project, we've started using this with admittedly an engaged client who's an industry player in part of the energy sector. And yeah, so the views Amit was showing before regarding fuel use across different industries, and that it's just a more dynamic way of conveying the results from a model. Gives the client a chance to unpack into certain sectors in more detail if they want to, or particular regions. but looking at that across different scenarios. And yeah, the Sankey is a good example here because I got the sense they tried to build their own using other software, and when we showed them this sort of view with what we could produce, they were very excited and blown away in terms of how interactive it was. And I think it's like different years, and you know, just putting your cursor over, you could trace the flows in different sectors. So it's a very powerful way of conveying your results. But yeah, obviously you'd keep this for the more engaged client.
It's also very useful for diagnostics actually, because you can get such a wide view of your model so quickly, with a reporting system like this, and then drill down immediately. That's what I like, that you can explore and debug and synthesize all at the same time. So this is I like this because this shows the export story of Australia. Because here we know it's a very heavy coal and gas exporter. So how coal and gas can evolve to hydrogen export over time. So these charts are by time. In this scenario, the coal and gas exports are going to hydrogen. And when you put your mouse here, then it highlights that in each chart. So it's easy to see how things are changing. Now I'll stop talking.
Okay, any other questions or comments or whatever? I mean, how well is this part documented in standard manual?
I think it's quite well documented. So there are examples of the two ways of extracting. There are examples of these creating these aggregations, like demand segment to process map, everything that we have seen, and then how it shows up in the CSP.
Mm-hmm. Okay.
And then there's some LMU views also. These LMU views I think they link to live also. So I think yeah, the online thing is here. So if you want to see a live view, then you can click this and it will show you. So I would be happy to entertain questions on the forum, or and after people have had a look, because see, this is very different, a very different approach to reporting. It will take some investment, but as we saw with George, I mean, I think it took you 1 day to migrate.
Yeah, a weekend, let's say.
A weekend, yeah.
Yeah.
And so, and it I mean, if you are doing heavy reporting, then it will pay back immediately. So I would like people to try this, and that's why it is open to everybody till the end of this year. And there are examples. This this one, the advanced demo model that I used today in today's webinar is on GitHub as a public repository, and the EU Times model also has a fairly detailed reporting workbook, which has many different examples. So in fact, it is mentioned here. that this model has this file, which has a lot of examples for this functionality. So you can try the demo model, you can try it in your own models. Let me know what you think.
Okay. I don't see any other reactions or comments. Good. Okay, so I suppose we can close it here.